Now we will go into detail that how the thymus cortex is helping the T cells to undergo maturation. We have already discussed that in the bone marrow there are pluripotent stem cells, right, which can give rise to lymphoid progenitor cells. Lymphoid progenitor cell within the bone marrow convert into lymphoid stem cells. These lymphoid stem cells leave the bone marrow and shift to the blood, and through the blood they eventually reach to thymus cortical region in the cortex of the thymus, and this process is under, yes please, thymotaxin. We help in these cells to taxi around, right? Thymotaxin. So thymotaxin attract the lymphoid stem cell from the bone marrow through the blood to the thymic cortex. Once these cells come here, they undergo different phases of development in the cortex, and when they become fully mature T cell, they jump into thymic medulla, and eventually from the thymic medulla they come into general circulation and they settle down into different lymphoid organs. Now let's concentrate on this region, what really happens there. I will draw a big area here and we'll see what's going on. Let's enlarge this area here. Right? This is the thymic cortex and this is thymic medulla. Right? Now, from the blood, the cell which is entering here, what is the name of that cell? Lymphoid stem cell. So here is your lymphoid stem cell. Right? Now, lymphoid stem cell will come here. Right? It does not have any CD4 molecules. It does not have any CD8 molecule. It does not have any T cell receptor for the antigen. So we say that because it does not have any lymphoid stem cell, right, because it does not have any CD4 molecules or CD8 molecules, we call it is double negative cell. This is double negative cell. And of course, or in a simple way we can say it is CD4 negative, it is CD8, yes please, negative, and TCR negative. Is that right? It has not yet developed any special features related with the T cells. But once it come over here, there are thymocytes. What are these cells? Thymocytes. They are going to produce their product, and the products of the thymocyte will help it to mature. These products of the thymocytes are, what are these products? These are thymosins. They are thymopoietins, and serum thymic factor, and still some other factors. So these are the soluble products from the from the epithelial cell. Please correct it. These are not thymocytes. Thymocytes mean lymphocytes. These cells are epithelial cells which were endodermally derived, right? These epithelial cells which are present in the cortex of the thymus, right, they act as nursing cells. They are also called nurse cells. They are also called epithelial reticular cells, right? They help the T cell, incoming stem cells, to mature into proper T cell. Now first product is that when these soluble product interact with the newly arriving, what is this? Stem cell, right? They will activate a special group of gene, and this group of gene is the gene for TCR. This gene will be activated. Actually, what really happens, that special type of enzymes will be activated in these cells. Or if you really want to know very exactly, these products activate certain genes which produce the enzymes, and these enzymes are present within the stem cell. They are produced within the lymphoid stem cell. What these enzymes are doing? Right? These enzymes are produced within the lymphoid stem cell under the influence of thymosins and thymopoietin and other products by the epithelial cells. Now what are these enzymes doing? Right? These enzymes actually start playing with this gene. Now let me show that gene in a clear way. This is the gene, it has one variable region, it has some diversity region, some constant region, and right, multiple region. Or rather than going into detail, you just remember this gene has two parts, one part which can be rearranged and one part which is always constant. This gene has two parts. Now what really happens, these enzymes which are induced there, right, they are having special type of operate tools, and with these tools what these enzymes are doing, they start cutting and reorganizing this genetic material here. Is that right? So we can say they are making the new combination of genetic material. That is why these enzymes are called recombinases, right? They're product of the gene called RAG1. There's a gene called RAG1 and another gene which is called RAG2. These two genes produce the enzymes, and these enzymes are called recombinases. Now again, let's put everything in perspective. That what really happens, that in the thymus, epithelial cell produce a product. Those products activate the lymphoid stem cell. In the lymphoid stem cell, RAG1 and RAG2 gene produce enzymes called recombinases. These recombinases enzymes start making new combinations in this genetic material. Is that right? After making some combinations and changes here, they leave this genetic material. And this genetic material, after one shuffling, becomes stable for the life of the cell. It will be never played again. It is just like that. You have some cards and you shuffle the cards, and after making a unique combination, you never touch it again. Is that right? In the same way, recombinases play with these genes like they are playing with the cards. They shuffle a part of the genes and then they never touch them again for the life of this particular cell. Now, it means this will become a unique combination. From this genetic material, when you will make messenger RNA, this messenger RNA will be special, unique. This part of messenger RNA and this part of the messenger RNA will be constant. And from here, when you will make a protein, the peptide in this part will be variable and this part will be constant. Now, these peptide molecules which are synthesized into that lymphocyte, they will float on the surface. This is variable region which varies, and this is a constant region. In the same way, there is another molecule from another gene, variable and constant. Both of these are interconnect with each other. And you know what is that? T cell receptor. What they have synthesized? T cell receptor molecule. So this was a gene for T cell receptor. So what really happens, that recombinases were playing with the genes of variable regions of TCR genes, and TCR genes, right, they are altered and made a unique combination. After that, they constantly start producing messenger RNA and start producing proteins, and those peptides float to the surface and they become unique type of receptors to accept a special type of antigens. In this way, T cell gets pre-programmed. Now, if 10,000, attention please, come here. If 10 million T cells pass through this area, in every lymphoid cell, activation of recombinases, and by chance, do you think all of those combinations will be identical or they will be different from each other? They will be different. Is that right? Because recombinase enzyme play with these genes randomly. So but the beauty is that they only play once in the lifetime of the cell, and they only play and make recombination of these genes only in thymic cortex. They never play it again. So what really happens, that now let's put it in another way, that when lymphoid stem cell reach into thymic cortex, the surface does not have any TCR, the surface does not have any CD4 molecules or CD8 molecules, right? But the product of nursing cell activate the recombinase genes, and when RAG1 and RAG2 gene which produce enzymes called recombinases, those enzymes will make unique combination of TCR genes variable region, and after that TCR genes will produce the products which are called TCR. So when this cell will move forward, what has happened to this stem cell? Then now it has become TCR What is here? What is this thing? TCR positive, right? This is TCR positive cell. Now this, if 10 millions lymphocytes pass through this, all of them will develop TCRs, and due to randomness of the process, every cell may develop TCR which are different than the other cells. Is that right? But once gene has been played with or altered, after that it will be never changed again. So for the life of the cell will keep on making TCRs all his life, but all the TCRs on one cell will be same. All the TCRs on one cell will be same, but TCR from different cells will be different. That is the point you have to remember, that when T cells are developing, TCR genes are undergoing rearrangement, and once they undergo rearrangement, after that in a given cell they become stable forever. So a given T cell will make the TCRs, which will be, all the TCRs will be identical on cell membrane of one given T cell. But because variation in TCR gene and recombination of TCR gene is random from cell to cell, so if 10 million or millions of the T cells pass through the thymic process, right, it is quite possible that every T cell develops a TCR which is unique and different from others. Is that right? In this way, T cells are being prepared to react and recognize different T cells, recognize different antigens in future. Or we say we are programming the T cell to recognize in future a unique type of antigen or its epitope. Is it clear? No problem. This cell is now, once TCR molecules appear on its surface, it is no more stem cell. Now it is called pre-T cell, because yet it is not full T cell, so it should be called, yes, pre-T cell. And what was this? Stem cell. So stem cell convert into pre-T cell as soon as they start expressing TCRs. Any problem up to this? Then more product come and work on this cell, and now its cell undergoes more changes. Actually, two more genes are activated. Look here. In next stage, two more genes are activated. One gene will produce a protein which is called CD4. Other gene will produce a product which is called CD8. So, with further movement, as cells are maturing, they are moving from the cortex towards medulla. Is that right? Now, as it further develops, right, genes for CD4 and CD8 are activated. So this cell, which was already having, what it was having? TCR, it also become positive in CD4 molecule. Let's suppose these are which molecules? CD4 molecules, and let's suppose these are CD8 molecules. So there is a stage during the development of the T cells that they are, yes, they are TCR positive, they are CD4 positive, they are also CD8 positive, and because they are CD4 and CD8 both positive, they are called double positive cells. And at this stage, when they arrived, they were double negative because they were CD4 and CD8 both negative. But actually, truly speaking, they were triple negative, because they were CD4 negative, they were CD8 negative, as well as initially they were TCR negative. But first they developed the TCRs and programmed themselves to recognize a unique antigen in the future, unique and specific antigen. After that, they start expressing CD4 and CD8. Is that right? Okay. If you really want to make it in diagram more easy to remember, let's modify the diagram. See, these are CD4 molecules. What are these? CD4 molecules, and along with that they also develop CD8 molecules. So double positive. Is that right? Now the next development. As they will move forward, another test. Now we have to check them. We have to do certain tests. I will extend the cortex a little bit more. Now, in the next stage, this nursing cell will check. Now, what they will check about these cells? Okay, they are being nursed. They should be happy or sad? All right. They're very happy, they're double positive. Is that right? Initially they have only TCRs. And when they came, they had nothing. So they must be sad. Right? This is stem cell. Then convert into which cell? Pre-T cell with TCR positive. Now they're double positive. That TCR positive plus CD4 and CD8 positive. Now, after that, their test will come. What is the test? We'll test these cells. Yeah, what is the test?
Probably to make sure that the receptors aren't the receptors for the proteins for the cell.
Okay, you are right. Let me explain. Yeah, you are right. Actually, now these nursing cells will offer these cells with, yeah, what? They will offer your self class 1 molecules and class 2 molecules. So actually, they will now start offering which cells, which molecules to these cells? MHC molecules. MHC molecules. Right? Now listen. These, you must be knowing already that CD4 recognize class 2 molecules, MHC class 2 molecules, and CD8 recognize MHC class 1 molecule. But actually, if this cell is developing in my body, then they should be able to recognize class 1 and class 2 molecules of Najib. If they are developing in, suppose, his body, then his developing T cells should be able to recognize class 1 and class 2 of Mr. Hassan. Right? So actually, now, if it is my thymus, then they should be able to offer, of course. My thymus was working when I was younger, anyway. So they should be offering my class 1 and class 2 molecules. My class 1 and class 2 molecule of major histocompatibility system. And any T cell which recognize, my own class 1 and class 2, now they will offer my own class 1 and class 2, and according to that, all the developing cells can be divided into two. Right? Some of them will recognize, some cells will recognize my own class 1 and class 2, and some cells will not recognize my own class 1 and class 2. Let us suppose that this cell does not recognize my own class 1 and class 2. And this cell recognize my own class 1 and class 2. Again, of course, all of them are positive in TCR, and both are positive in CD4, as well as they are positive in CD8, positive in CD4 as well as in CD8. Now they are being offered what thing? My own class 1 and class 2. They should be able to recognize. But because receptors are being formed randomly, not only TCRs are being formed randomly, CD4 and CD8 are also made randomly. So there will be some cell definitely which will not recognize my class 1 and class 2. And in future, we want that in my body, antigens should be recognized by the T cell in association with my own class 1 and class 2. So those T cells which do not recognize my own class 1 and class 2 molecules, these cells will become very angry. These nursing cells. Is that right? And what they will do with that cell? They will express their Fas ligand. And there is a Fas receptor here. And this is a death molecule. Is that right? This nursing cell, when it finds that there is a lymphocyte which is not recognizing the self class 1 and class 2, it will express a molecule called Fas ligand. And normally, lymphocytes do have Fas receptor. When this and this cell undergo interaction, Fas ligand stimulate Fas receptor gives signal. Okay. Now it should be very, very sad, isn't it? Right, this was not recognizing my own MHC molecules. So epithelial cells or nursing cells are no more nursing, they become death cell. They express the Fas ligands and stimulate Fas receptor, and Fas receptors give intracellular signal for programmed cell death, and these cells will die. So as cells are developing, only those cells are allowed to proceed further, right, which can recognize my own class 1 and class 2, which can recognize self class 1 and class 2. And those lymphocytes which are developed in such a way that they cannot recognize self class 1 and class 2, they are eliminated. Is that right? So this is called, now listen, it means this group of cell is selected and that is not selected for the future performance. These cells which are selected, they were reacting with the offer. What was the offer? Self class 1 and class 2. So all those lymphocytes which are trying to exit, right, they're offered self class 1 and class 2, and which recognize the self molecule, they are positively selected, and those which do not recognize, they're negatively selected. Positive selection means they are allowed to proceed in the process. Negative selection means they are induced, they undergo the process of induced cell death or apoptosis. What was your question?
I thought that the thymus killed the T cells that had the receptors to attack.
We will talk about that. Understand? We'll talk about that. So this step is called, what was this step? Yeah, what was this step called? Positive selection, negative selection? Positive selection. But you have to remember which developing lymphocytes are positively selected. These are now immature lymphocytes. Right? These are called immature lymphocytes. Which cells are positively selected? Which do recognize self class 1 and class 2 molecules. Is that right? So this is ensured that only those cells will go to the peripheral part of the body which will in future recognize self class 1 and class 2. No question? Now after that they have to give one more test. I think it's something like a medical school. They have to give one more cell test. Again, now this nursing cell offer self-antigens. Other self-antigens other than class 1 and class 2. Now, under this process, again, these lymphocytes will be divided into two. Some will recognize the self-antigens, and some will not recognize. Let's suppose that this is recognizing the self-antigen because it has such TCR which could recognize the self-antigen. It has a different TCR and it does not recognize the self-antigen. Any cell which recognizes the self-antigens, it means in future it will react with our own antigens and it will attack our own tissue. So it will become a source of autoimmune reaction. Do you think body wants it? No. So what really happens that first we check at this stage we are checking the developing lymphocytes that do they react with the self MHCs or not. Those cells which were recognizing the self molecules, they were positively selected. Which were not recognizing, they were negatively selected. Is that right? So this is called positive selection. Positively selected lymphocytes have to go under one more test. Is that right? And test is that they are offered our self-antigen other than class 1 and class 2. Now, because the development of TCR was a random process, so it is quite possible that some of that developing lymphocyte may have developed such TCR which could recognize the self-antigens or autoantigens. Right? For example, this one is which recognizes the autoantigen. As soon as it recognizes autoantigen, this nurse cell know that it is going to be a trouble in future. So they immediately express again what? Fas ligand. And this cell which recognizes the self-antigen undergoes auto-death process. Is that right? Opposite to that, those lymphocytes, right, which do not recognize, which have such TCR, which do not interact with the autoantigens, right, they are allowed to proceed forward. Now listen carefully. In early stage, we selected those cells which were reactive to self, class 1 and class 2. So these were positive selection. But here we are selecting those cells which are not reacting with autoantigen. So this is called negative selection. So this stage is called negative selection. Is that right? Now, in the end, now we are having here negatively selected cells, and let me explain what is the real situation there in the negatively selected cells. These negatively selected cells, they are TCR positive, they are TCR positive, but they are having such TCRs which do not react with the autoantigens. Is that right? Number one. Number two, they are CD4 positive as well as they are CD8 positive. Is that right? Now these cells are about to exit, but at the junction of cortex and medulla, there's a final test for it. These cells which are going there. Right? Now these cells convert into very loving cell. Which cells? Nerve cells.
Is that the same as the epithelial?
These are still epithelial cells. These are all epithelial cells which are helping these cells and nursing these cells to develop into right direction. Right? And cells which are unwanted and dangerous, they are killed within the cortex. So many lymphocytes are killed within the cortex and their breakdown products are eaten up by the macrophages. Is that right? That is why many macrophages are also present in the cortex. So cortex has a lot of epithelial cell and they have a lot of lymphoid cells tightly packed and they have a lot of macrophages. Yes, please, you have a question? You're just moving the... Okay. Now, so this is happily selected TCR positive, CD4 positive, CD8 positive. It is still double positive, but it has gone through positive selections and negative selection. So after this selection process, this is a cell which can recognize self class 1 and class 2 molecules, but it does not recognize other self autoantigens. Is that right? Now, this cell will be offered another way. These are two nursing cells. One cell is offering class 1 molecule, MHC class 1 molecule, and other is offering MHC class 2 molecules. Now these molecules are offered to them and they have to pass through this area for the final development. When these cells at the junction of corticomedullary junction, right, when these cells which have gone under negative and positive selections, when they are passing to the final step, they are offered class 1 and class 2 molecules by the nursing cells. It is just by random chance that if class 1 touches it first, it will touch which point? CD8. If class 1 happened to touch it first, it will make its CD8 producing genes on forever and off the gene of CD4. And if class 2 molecule by random chance touches the CD4, CD4 gene will be activated forever and CD8 gene will be turned off. So due to that reason, the cells which will eventually jump from here to medulla, right, these lymphocytes will have such TCRs which can recognize only foreign proteins, and either they will be CD4 positive or they will be CD8 positive. They can never be double positive now. So actually converting the double positive cells into single positive cell is a function at corticomedullary junction where these double positive cells are offered class 1 and class 2 molecules. Those lymphocytes which get class 1 molecule first, class 1 interact with CD8. So they decide to remain CD8 positive and down-regulate their CD4 molecules and also switch off the genes to produce CD4 molecule. Is that right? And those cells which are going out and by chance they are offered first class 2 molecules, class 2 interact with which surface molecule? CD4. Right? You have to remember that CD4 interact with class 2 MHC molecule and CD8 interact with class 1 MHC molecule. But double positive cells have a capacity to recognize class 1 and class 2 both. But if they are offered, again, it's worth revising. If by chance this double positive cell, some of the double positive cell are offered class 1 first, so they become CD8 positive cells, and some are offered class 2 first, so they become CD4 positive cell. So by the time they jump here, now they're mature lymphocytes, and these mature lymphocytes are TCR positive. They are TCR positive plus they may be CD4 positive CD4 positive, or they are TCR positive and CD8 positive. Is that right? Now, about these lymphocytes, now they have been through all the successful process, right? They are, I think they must be dancing around. Right, they have gone through all their training, right? They are in the medulla, and from the medulla, now this is medulla, here these lymphocytes have reached. Now look at this diagram. Let's rapidly discuss it. Just as a revision and see what happens. Step number 1, that in the bone marrow there should be pluripotent stem cell. Is that right? Step number 1. Step number 2, there should be generation of lymphoid progenitor cell. Step number 3, there should be generation of lymphoid stem cell in bone marrow, lymphoid stem cell in blood, lymphoid stem cell in which cortex? Thymus cortex, not cerebral cortex. Right, thymus cortex, right? So when they reach into thymus cortex, initially they are double negative. Is that right? Then they become TCR positive. Then they become double positive, and of course, then they undergo two selection process. Positive. No, first there should be positive selection or negative selection. First there is positive selection, and then there is negative selection. Right? During the positive selection, those cells are allowed to survive which react with the self class 1 and class 2. And during negative selection, those cells are allowed to survive which do not react with the autoantigens. And after that, when they are about to jump, they are offered class 1 and class 2 molecules. Those cells which receive class 1 first, they become permanently CD8 positive cells, and those cells which come across class 2 molecules first, when they are jumping there, they become permanently CD4 molecules. In this way, mature lymphocytes are there. These lymphocytes from the medulla, through the lymphatics and through the blood, go to general circulation. In the general circulation, eventually some of them keep on circulating, others settle into lymphoid tissue, especially in those areas where T cells are normally settled. Later on, we will discuss T cells are specially settled in paracortical area of lymph node. We will discuss it in next lecture. And T cells also settle in pals. Pals is periarterial lymphocytic sheath present in the central arteries of spleen. In the spleen there are special arteries, and around those arteries T cells are aggregated. T cells are aggregated. So this all grouping of T cells around the artery is called periarterial lymphocyte. What is this? In spleen, right? So this collection, these are special areas where T cells are settled. Moreover, some T cells go and settle into where? Into Peyer's patches in GIT and other parts of the body, right? In this way, now we know from where the originally T cell originate. In very early level, they originate in the bone marrow, and where they get fully trained, thymic cortex, and from the thymic medulla they come into circulation. So they are circulating T cells, right? And there are T cell aggregates or groupings which are present in the paracortical area of lymph node and also in periarterial sheath. This is called periarterial lymphocytic sheath, right? So periarterial sheaths in the spleen. Is that right? And some other areas in the body which we'll discuss later. Do you have any question?
When these are randomly matured, I mean, these eventually become T helper cells, and the other one becomes
Of course.
right?
Then of course,
Are they equal?
CD4 positive cells become T
T helpers.
helper cells, helper naive. Because in future then antigenic stimulation with antigen presenting cell will convert them into T helper 2 or T helper 1, and these become T cytotoxic, CD8 positive. But some of the CD4 positive cells become T regulatory, and some of the CD8 positive cell also become T regulatory or T suppressors. right? So we can divide the T cells into T lymphocytes into T helper and T cytotoxic and T regulatory. Is that right? All the T, why don't I make it properly here?
How is
All the lymphocytes which come out, either they are T helper or they are T CD4 positive or CD8 positive, or is very important, and this is CD4 positive and some cells are CD8 positive. Now look, all the CD4 positives are T, what are these? These are T helpers. T regulatory or T suppressors, they are also called T suppressors, some people call it T regulatory. Some of them are CD4 positive, some of the T regulatory are CD8 positive. But there is no T cell which has CD4 and CD8 simultaneously. Is that right? And all the CD8 positive cells are basically T cytotoxic. Is that right? So again, from the thymic medulla, the cells will jump to the circulation. Either they are T helpers and all T helpers are CD4 positive, or they are T cytotoxic, all of them are CD8 positive. Some of them are T regulatory or T suppressor, which are mostly CD8 positive, but some may be CD4 positive. Another thing that what is the ratio of the T cells and B cells in peripheral circulation? Do you know something called TB? TB? Tuberculosis. So tuberculosis, T ratio to B is 3:1. Is that right? And so we can say in the peripheral circulation, for every 3 T cell, there is 1 B cell. It has nothing to do with tuberculosis, just remember. Is that right? TB, 3 for T, 1 for B. Is that right? And if you really want to go further into detail, we can make it, I think now my board needs to be enlarged. Okay, I will remove it now from here. Let's sacrifice this diagram, as sometimes in life you have to do certain sacrifices. Okay, let me make again some lymphocyte picture here. We have already discussed, but it's worth discussing again so things become more clear.
when it first enters the cortex, you said it's double negative. Isn't it triple negative?
It is double negative because when we mean double negative, it is CD4 and CD8 negative. But of course, it is TCR negative also. So just for your personal use, you can say it's triple negative, right?
I was more concerned with just saying that.
Just a minute. Let me decide lymphocytes. Lymphocytes, because we have not recorded it previously. Lymphocytes can be divided into, yes, B lymphocytes and T lymphocytes and lymphocyte-like cells, which are called natural killer cells, which are large granulated lymphocytes. Then, what are the speciality of B cells? B cells are BCR positive, B cell receptor positive, CD79 positive, and CD19, 20, 21 positive. This is the features of which cells? B cells. And whenever B cells are activated, they convert into plasma cells, which are oval cells having a nucleus which is cartwheel shape and having a very prominent Golgi body, which is saying that it is producing a lot of antibodies. Then T cells. All the T cells are TCR positive. All the T cells are CD3 positive. But actually, T cells should be divided into further groups. That is T helper cell, T helper naive. There is T regulatory cells or T suppressor cells, and here is T cytotoxic cells. Is that right? Now, all of these cells are TCR positive, all of these cells are CD3 positive. But special thing about T helper is that not only it is TCR positive, not only it is CD3 3 positive, but especially it is CD4 positive, right? About T regulatory, they are TCR positive, they are CD3 positive, and it's very important point. Some of the T regulatory are CD4 positive, and some of them are CD8 positive. Is that right? And it is strictly CD4 positive T helpers. But when we come to T cytotoxic, again, they are TCR positive, they are, yes, CD3 positive, yes, and they are CD8 positive. Is that right? Now you understand how they are thymus treated and why they become all TCR positive and why some are only CD4 positive and some are only CD8 positive. Then T helper cells under the influence of different cytokines. Either they are under influence of interleukin 4 or they may be under the influence, special influence of interleukin 12. If they are under the influence of interleukin 4, they convert into T helper 2, very good. And if T helper naive is under the influence of interleukin 12, they will convert into T helper 1. Is that right? Now, T helper 1 and T helper 2, they both produce interleukin 2. They both produce interleukin 2. This interleukin 2 act on these cells, plus some of this interleukin 2 can also act on T cytotoxic to stimulate it. Interleukin 2. But very special products from T helper 2 is
4 and 5.
interleukin, yes, 4 and interleukin 5. Interleukin 4 is B cell growth factor. Interleukin 5 is B cell differentiation factor. T helper 1 produce very special product, yes, tumor necrotic factor and gamma interferon, and both of them can act on the macrophages and convert them into superactive, very active macrophages, right, or into modified epithelioid cells macrophages which are almost sleeping. Is that right? Clear? And T helper 2 with B cell and plasma cell are component of humoral immunity because they are leading to the development of antibodies. But T helper 1 with the macrophages are component of cell mediated immunity. And T cytotoxic are also part of cell mediated immunity. Is that right? This is what we have discussed in last lectures. Natural killer cell we discussed previously. Why we call them natural killer cell? Because they naturally kill, they don't need specificity. You know that activation of T helper cells and activation of T cytotoxic is through TCR, and they are activated only with a specific antigen. Even B cells have BCRs which can be activated only with a very specific antigen. But natural killer cells are non-specific in their killing action. Due to that reason, we say that they are BCR negative, TCR negative, CD3 negative, even B cell marker like CD19, 20, 21 also negative. So natural killer cells are negative for the surface marker of B cells, the negative for the surface marker of T cells, even CD4 and CD8 also negative. Is that right? But natural killer cell naturally kill, they are not part of adaptive immune system, they are the part of innate immune system. Right? What I really mean by this, that innate immune system, they are non-specific in their action, and with repeated exposure, their number does not increase. Right? How the natural killer cell kill? There are three mechanisms by which they kill. Number one, any cell which does not express self class 1, no self class 1 molecule. You know, every cell in your body, all nucleated cells are supposed to express your own class 1 molecules. If natural killer cell come across a cell in your body which is not expressing class 1, natural killer cell will kill this cell, right, by producing the perforins and by producing the granzyme and by fast interaction apoptosis. So all the cells in your body which are not expressing your own class 1 molecules, natural killer cell kill them. Now what are those cells which do not express your own class 1? Some of these cells are infected by viruses. Some virus down-regulate the gene for class 1, so your cells do not express your class 1. So natural killer cell will kill those viral infected cells. Or some of your tumor cells switch off the class 1 gene. So those tumor cells which are without your class 1, they are also killed by the natural killer cell. Thirdly, if some other person tissue is transplanted into you, of course other person cells or donor cell, right, they express class 1 of the donor, they do not express the class 1 of the recipient. And recipient natural killer cell, when they're looking for the recipient self class 1 and they don't find on the donated tissue, they again kill that, right? So this is how non-specifically they can kill virally infected cells or tumor cells or transplanted tissue cells. Is that right? Moreover, some tumor cells express a special type of proteins which are called mica protein, M-I-C-A, mica protein. And these, you can say, okay, I'm making one natural killer cell. Number one, it has a receptor to recognize self class 1. Natural killer cell is very serious type of cell, right? So number one, it has receptor to recognize the self class 1, and whenever on any cell it finds self class 1, it does not damage that cell. It's very important. Natural killer cells are the cells which scan all your cells for the presence of your own class 1. Your own cells are expressing your own class 1, so they don't do the damage. But whenever they come across a cell in your body which is not expressing your own class 1, they will immediately kill. We have seen the example. Number two, natural killer cells have receptors for mica. Receptors for mica. Mica is a protein which may be expressed on some of the tumor cells. And whenever natural killer cell engage the receptor on the mica, they kill the cell. They come to know this is abnormal cell. Thirdly, that natural killer cell, not only, they also are having a receptor for antibody. They have a receptor for IgG. So if there is a cell on which IgG is present, what is this? IgG. And if a natural killer cell come here and engages with this receptor, right? So it assumes that if IgG is present on this cell, it means this cell is having some antigen against which our antibody is fixated. So this cell should not be there. So it will kill that cell. So let me recap. What are natural killer cells? They are wrongly classified as lymphocytes. They are not lymphocytes, even though they look like a large granulated lymphocyte, but they are not truly lymphocytes, because B lymphocytes and T lymphocytes are part of the adaptive immune system, which can be stimulated only by exposure of the antigen, and with repeated exposure, B cells and T cells amplify their responses. And T cells and B cell responses, by the virtue of their antigen specific receptors, they only respond to specific antigens. But natural killer cells do not have any specific receptor for unique type of antigens. They are non-specific killers. Number two, natural killer cells do not need prior exposure for their activation. Number three, natural killer cell, by repeated exposure of particular antigen, natural killer cell activity is not enhanced. So all these things tell you that natural killer cells are not like B cells and T cells. And if you are wise, you will look for the surface marker of the B cells and T cells on the natural killer cell. Natural killer cells do not have the surface markers of B cell. What are the surface markers of B cells? BCRs and CD79 and CD19, 20, 21. They are not present on natural killer cell. In the same way, natural killer cells do not have the surface marker of T cells. They do not have TCRs, they do not have CD3. But then how they recognize the target cells? If they don't have BCRs and TCRs, answer is that they have non-specific receptors. They have one type of receptors which will recognize the presence of self class 1. Number two, receptors which will recognize the mica protein. Number three, receptor which will recognize the IgG. But remember that these receptors, this receptor and this receptor, give positive signal for the cell, and this give a negative signal. It means if okay, make it keep it simple, that whenever natural killer cell visit any cell in your body, it should get its class 1 recognizing molecule engaged. If this is not engaged, then it take that cell as a foreign cell or modified cell, right, and it will kill that. So number one condition in which natural killer cell is when they find a cell in your body which does not expressing self class 1. These may be virally infected cell or tumor cells or foreign cells in your body, transplanted cells. Or natural killer cell will attack the tumor cells which express mica proteins, or natural killer cell will attack the cells which are having IgG fixated on them. Is that right? Any question up to this? So we have done just today T cell development, and in next lecture we'll talk about B cell development along with the detail of the lymph node and spleen. Class dismissed.